So this is going to be a demonstration for how to do some of the problems from the Solving Literal Equations worksheet, which has been uploaded to Schoology. So the first question we're going to go over is question number 2. And in question number 2, you are going to be solving for the letter A. So within this question, there exists one A. And this is not like a traditional equation where you're going to be solving for a number. You actually need to get the A by itself. So with the A, we have this M. To get rid of the M, since it's currently positive, we're going to subtract that M from both sides of our equation. Z and M are not the same variable, so I cannot combine them into a single term. They have to stay separate. And I have Z minus M is equal to A for the first problem. All you're doing is rearranging the equation so that the indicated variable, which you can see in all the problems, it says 4x, 4a, 4a, 4x. You're going to be getting that variable by itself. The next question I'd like to go over is number 5. Number 5, you're once again solving for A. And A exists once. A is being multiplied by an M. So to undo multiplication, you are going to divide. So I'm going to divide both sides of this equation by an M. The M's divide out on the left-hand side, and you're left with A equals. And whenever you have a fraction that is divided by a term, that term is actually going to go in the bottom of the fraction. So this is going to be P over M N. And again, it doesn't matter if you put the N before the M, but the M and the N do need to be both together in the denominator. And if you're wondering, well, why do you need to put the M in the denominator with the N whenever you are dividing? And that has to do with your fraction rules. So if we have P over N and we are dividing it by M, because that's what I have on the right-hand side of my equation. Anytime you're dividing with a fraction, that is the same thing as multiplying by the reciprocal. So P over N divided by M is the same thing as P over N times 1 over M. And whenever you do that, you multiply fractions straight across, and that's how you get your P over M N for your solution. So the next question that we're going to go to is number 8. And this one is a little bit different because you actually have the variable that you're solving for twice in the equation. We're solving for x, we have an x in the top and an x in the bottom of our equation. With these problems, whenever you have fractions, it's almost always a good idea to eliminate the existence of the fraction if what you're trying to solve for is in that fraction. And since we have an x in the bottom of this fraction, I do want to eliminate that. So I'm going to start off by multiplying both sides by x. So on the left-hand side, I'm going to have ukx equals, and then on the right, x plus y. These x's divide out, so I'm just left with the numerator, which is x plus y. Now again, x is on multiple sides of my equation. I need to gather the x terms together so that they are both on the same side. To do that, I'm going to subtract the x over so that it is on the left with the other terms. So I have ukx minus x is equal to y. Now all my terms that have x in them are collected on the left-hand side, and the terms that don't have x are on the right-hand side. However, there's still one more step that we have to do before we can really divide or move anything else away from the x's. These terms are not alike because the first one has a u and a k in it, and the second one does not. So I can't combine them into a single term, but I can factor the x out of both of those terms. So when I factor the x out, which remember factoring is really dividing, it's undoing distribution. When I factor the x out of the first term, I am left with a uk. The second term, and this is one of the big mistakes that I see students make, when you factor an x out of a negative x, you are left with a negative 1. I'm going to think about it this way. X times what number would give us a negative x? Well, x times negative 1 would give us a negative x. You always have to be able to redistribute and get exactly what you had in the previous step. And again, that's equal to y. We have x times a set of parentheses now, so I am able to undo that by dividing by the set of parentheses. So I'm going to divide both sides by UK minus 1. These UK minus 1's divide out, so your solution is going to be x equals y over UK minus 1. Our next question, and again, I think this is on my next slide here, and the last question that we're going to go over is question number 16, and this does have a lot of letters in it, and it is somewhat similar to the last question. I'm solving for A. I have an A on the left and an A on the right, except for there are a few more letters involved, but the process is still very similar. You want to gather your A's so that they are both on one side of your equation, factor the A out, and then divide by what's left. So I'm going to move all of my A's over to the left-hand side, which means I have to subtract this BA term. I also need to move this K term over to the right, so I'm going to be subtracting that K term as well. So the K term is gone from the left, the BA term is gone from the right. I'm left with A minus BA is equal to B plus W minus K. So A minus BA, this is where I factor that A out, so I can get the A on its own enough that I can divide something. When I take the A out of the A, I'm left with 1. Remember, you cannot factor and get 0. If you take everything out, you still have that 1 left over. So we have 1 and then a minus B. When I take the A out of this BA term, I'm left with the B. And that's equal to B plus W minus K. We would finish this out by dividing both sides by the 1 minus B. And so your final solution is A equals B plus W minus K over 1 minus B. And it's not necessary to keep the parentheses in the 1 minus B for your final answer, but you can if you want to. So I hope this was helpful. I hope this can help you solve your problems. And again, if you have any questions, please contact me.